Research does not end in the lab. The final, verifiable stage of the scientific method is the writing itself. A published paper functions as a strict blueprint, built so that peers can test and reproduce the exact claims. This requires precise communication rather than literary flair. Researchers cannot rely on ornamental language or assumptions about what the reader knows. Every chosen word must communicate an exact meaning, because authors must defend every phrase they publish. This standard is defined as intellectual rigor. The writing must be absolutely accurate, clear, and free of ambiguity. It is a highly controlled environment where the validity of the conclusions rests entirely on the clarity of the evidence. To maintain this rigor, the Committee on Publication Ethics establishes strict codes of conduct. Two pillars are non-negotiable: data integrity, meaning zero fabrication or exclusion of contradictory data, and authorship integrity, ensuring everyone who made substantial contributions receives proper credit. If an author fails to communicate clearly or breaches these ethical protocols, the brilliance of the laboratory experiment is irrelevant. Poor communication or ethical lapses invalidate the research, rendering the data useless to the scientific community. Plagiarism extends beyond direct copy-pasting. It occurs anytime a researcher fails to attribute borrowed ideas, specific methodologies, or structural fragments from another author's work. A common mechanical pitfall is patchwork writing. This happens when authors stitch together quoted sentences from multiple sources without developing their own synthesis or maintaining a logical progression of thought. Correct paraphrasing requires a different approach. The author must understand the core concept completely and rewrite the idea entirely in their own structural language while citing the original source. Editors actively screen for overlap. Journals run submitted manuscripts through software like Turnitin and iThenticate, which compare the text against vast databases of published materials to detect exact phrases and missing attributions. These anti-plagiarism protocols serve a specific function. They exist to filter out unearned credit and ensure high-quality scientific publication, thereby protecting public trust in the validity of scientific findings. Every piece of research writing, from a 10-page clinical study to a 200-page dissertation, relies on a strict structural architecture to organize complex information. It begins with the abstract. This executive summary condenses the entire study. It delivers the objective, the core methodology, and the major outcomes in a highly concise format so peers can immediately assess relevance. Next is the introduction. This section summarizes the necessary background literature and explicitly defines the research gap, clearly stating the exact novelty and objective of the current study. The methodology follows as the replicable blueprint. It details the exact techniques, formulas, and data collection methods adopted, providing enough detail that another lab could duplicate the study. This graphic demonstrates how the scope of the paper shifts. The results section sits at the narrow center, presenting pure, uninterpreted data and figures. The paper then broadens into the discussion, where authors interpret those findings and compare them against existing literature. Finally, the conclusion provides a brief 100 to 150 word synthesis of the outcomes and outlines the future scope for subsequent research. This rigid IMRAD structure ensures predictability. It allows global peers to quickly navigate the document, locate exact data, and independently verify the scientific claims. Once the manuscript is drafted, it enters the submission stage. The immediate technical challenge is identifying a journal whose scope matches the topic of the research. Authors must vet publishers to avoid predatory journals. These entities collect publication fees without providing rigorous peer review, compromising the integrity of the work. To locate legitimate options, researchers use journal finder tools. By inputting the paper's title and abstract, smart search technology matches the specific vocabulary of the research to relevant scientific journals. These databases generate specific evaluation metrics for each match. Authors can review the site score, impact factor, and time to first decision, while noting acceptance rates to gauge the probability of publication. Upon submission, the manuscript undergoes preliminary scrutiny for scope and formatting. It is then sent to a minimum of 3 subject matter experts for formal peer review, evaluating the methodology and data genuinity before the editor makes a final decision. Meticulously targeting a journal that aligns with an abstract prevents immediate desk rejection by the editor, accelerating the timeline for peer review and knowledge dissemination. Throughout the paper, referencing provides a mechanical system of attribution. It creates a verifiable, backward-facing trail of evidence for every claim. Journals require strict adherence to specific citation styles, generally falling into one of 2 primary methods: numeric systems or author date systems. The numeric method, or Vancouver style, is frequently used in medical journals. Citations appear as bracketed numbers in increasing order within the text, corresponding directly to a numerically ordered bibliography at the end. Conversely, the author date method, such as the APA style used in the social sciences, places the author's name and publication year directly in the reading flow, linking to an alphabetical reference list. Regardless of the style, the bibliography entry requires precise standardization. Every reference must include the author's full name, the article title, journal name, publication year, specific volume and issue numbers, and a digital object identifier. Flawless formatting in the reference list is a non-negotiable requirement. It proves the researcher's meticulousness and guarantees that original authors receive accurate credit for their ideas. Drafting a manuscript requires specific technical tools. Standard word processors manage basic text effectively, but they struggle to maintain complex structural formatting across lengthy documents. Features like search and replace or spell checking are helpful for initial drafting, but high-level academic publishing demands greater control over the final output. LaTeX operates as the professional standard. It is a typesetting environment specifically designed to compile complex academic papers, particularly those requiring intricate mathematical formulas. LaTeX works by separating content creation from formatting. The author focuses purely on the logical structure and text, while the compilation system handles the precise typesetting parameters automatically. Upgrading to professional compilation tools eliminates frustrating formatting errors and ensures the final document seamlessly adheres to the publisher's strict submission guidelines. Once published, researchers often translate their dense manuscripts into visual formats, specifically for academic conference posters. A common error is treating the poster board like a document page, filling it with tight blocks of text. The primary objective is immediate readability from several feet away. Professional poster design relies on spatial rules. It establishes a logical visual flow that naturally guides the reader's eye from the top left introduction down to the bottom right conclusion. Heavy paragraphs are replaced with high-contrast section headers, bulleted summaries of the methodology, and large, dominant data charts placed securely in the center. An academic poster is a heavily engineered visual summary. It is designed specifically to capture attention quickly and spark professional conversation among peers.